Hello everyone, welcome to another video of Ccna tutorial. So the today topic is IP address. We are slowly moving towards our practical lectures. So the first topic or the first lecture before starting our practical is the IP address. So guys, when you're hearing about the IP address, or usually you're getting a little bit like you're wondering that what is IP address. You're definitely I'm sure that you have definitely heard about this IP address before, maybe somewhere if you are an IT student. It's really not that much worrying thing. So it's a logical address. Logical in the sense it can be changed. It can be changed. We have two type of addresses, guys. You know, we have physical address and we have logical address. So the physical address is the one who is not changeable. The physical address is not changeable. It is already born, so you cannot change it. So for example, that is MAC address. MAC address is the physical address, which is born in NIC, Network Interface Card. So it's not changeable. It's born by the manufacturer of that company. For example, your laptop is from your laptop is from Dell company, then the NIC address or the manufacturer company who is producing this NIC for you is going to born or going to hack that IP address on your NIC, so no one can change it. But logical address means that it's changeable, so you can change it every time. For example, right now the practical for how to assign IP addresses in the next videos. But just to show you, for example, in my computer, if I want to change the IP address anytime, I can change it very easily. I will just go to the interface and I will assign here any type of IP address. For example, 10.1.1.100 to 55. For example, 10.1.1.1. Don't worry what's IP address, what subnet mask, and what is default. You know, just we are studying about the IP address, so I'm assigning an IP address for this. See, the IP address has been assigned. Later on, I can change it for some other IP address. It really doesn't matter. For example, I can change this one. For example, I can change even totally all the IP addresses. 192.168.1.1, let's say. Any type of address. So this IP, the default gateway is not matching. Okay. So let's change it to 192.168.1.100. So you can easily change. I think this one is already assigned, so let's change this to 2. Yeah, so you can change it anytime if you want, depending upon your choice. So logical means that it's changeable. So, but what is IP address, guys? For any node, whether that's a computer, means your laptop, whether that's a printer, for example, let's say for like fax machine, let's say, or for example a phone, mobile phone. Any node who is operating or who is using network is having an IP address. So for example, in your computer, you're right now using an internet, so you definitely have an IP address. When your mobile phone, you're using internet, so you're definitely having an IP address. So, but what is this IP address? This IP address is a logical address, which differentiates your machine or your computing device, or better to use not differentiate, you can say, which identifies, because it's a correct term, identifies your computer in a network. So what does it mean? For example, there's two PCs in my network, and if these two PCs wants to communicate with each other, so the PC A will not have any information about PC B. So if the PC A wants to communicate with the PC B, so both of them must have an IP address, because name is not used in technical. They both must have an IP address. So overall, to say, for any type of communication, if you want to build a network, we must have IP address. So, but what is this IP address? IP address is an address which identifies your computing device in a network. That address can be of two types. That address can be of two types. The first type is IPv4 address, and the other one is IPv6 address. IPv means version, IP version 6 address. The first or the initial technology which was used for IP addressing was the IPv4. So it was the first technology or the initial technology which even nowadays people are using it. But the newest technology, IP version 6, is the newest technology where some of the companies are using it, but some of the companies may not use it. So you will ask me why there's newest technology and older technology. What is the difference between IP version 4 and IP version 6? To know the difference, you should know the architecture of IP version 4. IP version 4 is a 32-bit. IPv4 is a 32-bit address which can be represented by two ways. What are those two ways, guys? The first one is binary. It can be represented by binary and it can be represented by decimal. So this IPv4 is a 32-bit address which can be represented by binary and also by a decimal. But this 32-bit has a specific type of structure. What is a specific? This 32-bit has divided. It's divided into 4 octets. 4 octets means 8 bits. What I'm saying is, after each bit, there's a separating character. Which is dot. So what I'm saying is, let's say in binary numbers, let's say we are representing the IP in a binary number. So it's 32-bit device. For example, 32-bit binary number. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's say this is a 32-bit IPv4. I don't know whether it is 32 or not. Just let's say it's 32. And after each 8 bits, we have a separating comma. For example, 1, 2, 3, 4, 5, 6, 7, 8. So there's a dot. 1, 2, 3, 4, 5, 6, 7, 8. So there's a dot. 1, 2, 3, 4, 5, 6, 7, 8. There's another dot. 1, 2, 3, 4, 5, 6, 7, 8. So the rest is unuseful. Yeah, let me delete this part. Yes, 1, 2, 3, 4, 5, 6, 7, 8. So this is an IP address. This number and binary represent an IP address. So actually IPv4 address, not IPv6 address. So means that IPv4 address is a 32-bit address which is divided into 4 octets. Separated by what? Separated by a dot character. Now, for every network in this world, for every device, for example, you have mobile phone, you have laptop, you have some other devices. To communicate in internet, they must have an IP address. And that IP address must be unique. Must be what? Unique. For example, unique in the sense, let's say if this IP is used by your computer, then this IP must not exist anywhere else. So if this IP is used by your mobile, so it must not exist by any other computer. So for other computer, you must have any other combination of this IP address. For example, let's say like this. Any type of IP address, let's say. I'm just demonstrating. Please don't get me wrong if there's a extra bits or not. But just what I'm saying is count as 32 bits and separate them by 8 octets. So this address must be unique. Now, so if we see, if you know the combination or the permutation formula in mathematics, so overall, how many number of IP addresses from IP version 4 can be extracted? Since each bit can have 2 states of 1 and 0, so overall I can say that 2 raised to power 32 number of IP addresses we are going to have, which is almost around 4.2 billion IP addresses. You just use your calculator. I don't know how to use the scientific calculator. 2 raised to power 32. Where was the let's say I think it is 32. No, so it's not the function of this. Yeah, I got it here. 2 raised to not power of 2. I need power of 32. No, I cannot use it actually. So if you can use it, you just count it actually, guys. 2 raised to power 32. That's going to be more or like around 4.2 billion number of IP addresses. Means we can have this many device in the world. Now imagine, don't you think that this many devices is really less? Because right now like for example in the world we have more than 7.8 billion population, and among them, for example, a single person has so many devices. For example, 3 to 4 mobile phones. Now laptops are available. Now desktops are available. So if we count for a single person, we need almost like near about 10 number of IP addresses. So the IP version 4 going to be insufficient because it will provide 4.2 billion number of addresses. So the insufficiency or the lower number of IP version 4 has created a problem. The problem was that if after allocation of this many IP addresses, no one else device can access the internet. So this is a big problem. The solution for this problem later has made some of in technology we had made some of the solution. The solution was nothing, and we had the concept of public and private IP address. So these are the solutions, guys, but the solution we will study how to do nothing and how those people has done this solution, they apply this policy and this nothing or public private. But as of now, you just need to know the IP address. You don't need to wonder about whether you can use which IP address you should use. You can use right now, as of now, any type of address. Once we reach the concept of nothing, I will again repeat the same scenario which I explained. I will again repeat the concept of IP version 4 overloading or underloading. So the first solution was this, and later on, even right now, this solution is also insufficient. Still, we are facing the problem of lower number of IP addresses. So the better solution, they have created the newest technology, that's IP version 6, and there is not much difference. There's much difference. Obviously, there's so much difference, but in other CCNA level, I can just say you, and we will study this IP version 6 at the end of our CCNA. I can say you that just as of now, this IP version 6 is 128-bit address. 128-bit address. So, for example, if right now we have 2 raised to power 32, around 4.2 billion, and if we count 2 raised to power 128, now you compare it, it's gonna be around like 4 times of, if I'm not wrong, I'm not sure actually, guys. You just count for 2 raised to power 128 how much it would be, but I think it's around like 4 times of IP version 4, IPV4. If it was wrong, I'm really sorry about that. Right now, I didn't count it in calculator. So but it's 128 bits, again binary number, so it has 2 states, 1 and 0. So 2 raised to power 128 is going to be this many large number of IP addresses, IP version 6 addresses. So the how to use this IP version 6 and all are going to be in last chapter, but we will be dealing with IPv4 only in our CCNA and CCNP and all our lectures. So because still it's available in the network and technology, and we can use it everywhere. It's still IP version 4. Now, so this IPv4 was 32-bit address, which is separated by binary. As you know, right now here the representation of IPv4 in binary is very difficult for us, because see, people cannot remember so many 0101. If they want to try to remember 2 IP addresses, it will take more than 1 day to remember them. So the next representation of this IP version 4 address was using the decimal format. Decimal format is from 0 to 9. From 0 to 9 we can represent this. But how to represent this binary number into decimal format? So see guys, it is 8 bits, all of them separated. Each octet has content 8 bits, and they are all in the power of 2. So we already know that the power of 2 starts from 0, 2 raised to 0, then 2 raised to 1, 2, 3, 4, 5 till 7, because we have only 8 bits. 1, 2, 3, 4, 5, 6, 7, 8 bits from 0 to 7. So if we calculate 2 raised to the power of 0, if you have knowledge of conversion between binary and decimal, you already know in your college studies. But if you don't know, I will just give you how to convert binary into decimal, but not for all the bits. We can convert 2 raised to the power 8, power 9, power 10. But since our IPV4 is only 8 octet, or it's only 8 bits, so we only need to use this many powers. So 2 raised to the power 0 is 1, 2 raised to the power 1 is 2, 2, 3, 4, 3, 8, and 4, 16, and like moreover, 2 raised to the power 7 is 128. Now here, for example, we had an IP address here. The IP address was, for example, here. Let's say I will give another example. For example, 111011101. See, 1, 2, 3, 4, 5, 6, 7, 8 dot. So one octet is finished. Dot. For example, 111145678 dot. 1, 2, 3, 4, 5, 6, 7, 8. Let's say 1, 2, 3, 4, 5, 6, 7, 8. Yes. So this is an IP address, guys. Each octet represents 8 bits. Now you just separately convert each octet. For example, we will start from here. This octet has 1111011. You now correspondingly match the location of each bit with its corresponding decimal number. From left to right, we have 128, then we have 6, then 64, and the rest. So see, the first bit is 128, the second bit is 64, the third is 32, and also moreover like this. But how to convert it? Wherever there is a 1, so you just means the bit is on. The bit is on means you add the number, you add the corresponding number, corresponding decimal number of that. You add the corresponding decimal number of that. So, for example, here the first bit, which is representing 128, is on. So 128 plus. The second bit is also 1, that's on, so 64. The third is also on, that is 32. So the fourth is on, the fourth is off. So what is the fourth? The fourth is 16, so we will not add the 16, okay? So now the fifth is on. So let's see what is the fifth. I already remember it. I remember it, and also I recommend you to remember this too. So the fifth bit is 8. So let's add the 8. Then 6 is 4. 4 is also on, but 2 is off. 1 is on. So this is a representation of our 1 octet. Let's add them together. Add them together. 128 plus 64 plus 32 plus 8 plus 4 plus 1. So that is 237. So I will write this IP address as 237 dot. Okay. So the next one is going to be, I will directly use the calculator, guys. The second octet. Here, just see 1, 2, 3. First 5 are on. So I will add all of the first 5. 128 plus 64 plus 32 plus 16 plus 8 is also the fifth bit. See 1, 2, 3, 4, 5. Now the 4 is off, but the 2 is on plus 2, and the 1 is 0 is also off. So this, I think that's going to be 250 dot. Now see, all of them are off, only last 3 are on, means 1 plus 2, 3, 3 plus 4 is also dot 7, and this one also. Let's calculate this one. So the last octet, 128 plus 64 plus 32. Okay, so first 3 are on, then 16 and 8 is off, 4, 2, 1 is on, plus 7. Oops, yeah, there's some mistake, I'm sorry guys. 128 plus 64 plus 32 plus 7. So we have 230. What was the number? 231. Oh. So see how easily we convert one binary number into a decimal IP address. So as like this, more like this, you can calculate. For example, if they are all 1, 2, 3, 4, 5, 6, 7, 8 means all are 1, so that's going to be 255. If you add 128 plus 64, all of them, that's 255. If all are 0, means that's 0. All are off, so nothing is added. This was the convergence, but we are not going to use, don't worry, we are not going to use the binary number. We are going to use just only decimal number. For example, if we want to assign IP address for PCA, we will say that your IP address is like, for example, 192.168, for example, 1.1. We will not tell that your IP is, for example, if you just reverse back this 192 to decimal number, to binary number, then you should do the division of 192 into 2 and just count it. So you already know how to convert decimal into binary. But as an example, I show it for you. So now, guys, so it doesn't mean that. It doesn't mean for every node or for every PC you can add any type of IP addresses. You should. There are some rules. There are some rules of IP address. You cannot assign any type of IP addresses. So it says that you should use from 5 classes of IP address. So means there are 5 classes of IP address available, which we can select an IP address from them. What are those classes? Before knowing the classes, you should understand two things, two important things, or two important rule. One is first octet never can be 0. First octet never can be 0. For example, we cannot have an IP address like this 0.168.1.1. For example, we cannot have such an IP address, guys. Remember that the first octet cannot be 0. And again, there's a rule for the first octet. That is, the first octet cannot be 127 also. 127.0, for example, .1.1.1, let's say. This IP address cannot be assigned for a device because this IP address is for loopback. Loopback is an IP address which we are going to use them in order to check the state of our local machine, the machine that you are currently working. For example, right now I'm working with my laptop. I just want to know that whether my laptop or my processor or my system is up and running, whether the network in my system is working or not. So I will just type the IP address of my local address of local machine, 127.0.0.01. See, it shows me that reply is coming from 127, means you're up and running. Right now you can try out this IP address. This IP address is always fixed, and this shows your local host IP address. Another purpose of loopback are going to, during our lectures we will have the usage of this loopback IP addresses. So the first IP address cannot be 0 because it is not logical if an IP address has 0 in the first octet, but 127 is a logical number, but it's used for some other purpose. It's already reserved IP address. So apart from this two, so how many IP addresses we are going to have? We are going to have 5 classes of IP address. 5 classes of IP address. What are those 5 classes, guys? We have the first class as class A. The IP is from 1. First of all, you should know how to identify classes based on first octet. we are identifying, or we can say we are distinguishing IP address classes. IP address class. Based on the first octet, we are differentiating the IP address 1 to 126 if the range, if the number of first octet is from 1 to 126, from not 0, because 0 is not allowed. That's class A. And for the class B, it starts from 128. Why you not 127? Because 127 is not allowed. That's reserved for loopback to 191. And for the class C, the IP range is 192 to 223. For the class D, that is from class D, that starts from 224 to 239. And the class E IP address, the class E starts from which range? Oh, sorry. The class E starts from 240 to 255. So based on the first three, okay, for example, let me give an example. If I give an IP address 100.1.1.1, which class is this? Obviously class A. How do you know that? Because the first octet is between the range of 1 to 127. If I give you an IP address of, for example, 192.168.1.1, so how do you know that which class it is? That's class C, because the range is from 192 to 223. So that's class C. So I hope you understand it very well how to recognize what is the class. And guys, so the concept was how to assign IP address. So we can assign IP address from these classes, but depending upon our type of communication. We can use which type of class we want. Now you will ask me that what's the communication. There are three types of communication. One is Unicast. The second one is multicast, and the third one is broadcast. Unicast IP address, Unicast communication, or those type of communication which are one-to-one. For example, there is only one sender and only one receiver. Only one sender and one receiver. That can be like the sender can be the client and the receiver side can be our server. So this is a unicast type of communication. For example, right now I'm sharing this video and YouTube. That is not a that's as of now. If the single person is watching this video, so you're only my client, let's say. So this is a unicast because I'm sharing to you directly. But if say at the same time I'm the sender, but at the same time not only you, there are 2, 3, 4 people. For example, this is me, and there are, for example, 2, 3 or more than one. Just only what matters is that's more than one. Then that type of communication, the same data, that's not going to be different data. The same data is going to be transmitted for the more than one number of clients. So that is called multicasting. That's called multicast because we are sending from one person to a group of person. And the last one is broadcasting. See, there is a little bit small difference between the multicast and broadcast. Suppose there's an organization and it has, for example, 5 clients, or for example, it has 4 to 5 clients, and this is the manager of that organization, and these are all the clients of, so like for example, clients 1, client 2, client 3, and client 4 of that organization. In this organization, if manager wants to communicate only with C1, only with the client 1, or let's say with the only department IT, so this type of communication is called unicast. If the manager wants to communicate with more than one person, let's say 2 person, or let's say 3 person, then this type of communication is called multicast. But if say the manager says that I want to communicate with each and every one in the network, and no one can reject me, actually no, everyone must attend the conference, or let's say the meeting, then that type of communication is called broadcast. Means one to all. So if I just gave a name for them, unicast is 1 to 1. the multicasters want to a group, but the broadcasters want to all. So no one can ignore it. So everyone must watch. So for example, the TV channels, while they are publishing their data in cloud or in internet, so that's a multicast traffic, because until unless you don't switch to the channel signal or that frequency of that channel, you will not watch that movie or that TV show. But once you switch your frequency or you set your frequency to the channel, the frequency number of that TV, so you can watch it. So that's a multicast. But the broadcasters, if you want everyone to reply you, for example, you are a manager, or let's say this is a server, and the server wants to know the state of all the clients, so it will just ping. It will just ping the broadcast IP address of that network. For example, 192.168.1.255. Let's say. You will know how. I will just tell you that how to know that in which network we have what is the IP address of the broadcast IP. So once for example, I'm pinging 192.168.255, then all the clients in this network going to respond me back. So this packet is for everyone. I hope you understand this. So based on this type of communication, we are going to use different type of classes. If our packet is from, if our type of communication is the Unicast communication, so we will use this range, class A, B, and C. If our type of communication is the multicast communication, so what we are going to use on that area, then we are going to use multicast. This class D is used for multicast purpose, and the class E is not used, guys. It's just reserved class for special, I can say, special experiments. For example, just the trial, or can say just experiments. They're not for the public users. They're just reserved for some special purposes. So they are not used anymore. They are not used for the public area. But in multicast, yeah, we are using the multicast class D. In terms of their assignment of IP address, they are also different. In Unicast, IP addressing is different. The multicast IP addressing is different, and the class E is that's totally reserved. So it's not even, I don't know how that's going to be assigned or not, because no one have the knowledge about the spatial experiment. Any type of experiment it can be. So for Ccna and CCNP level, we are going to use all the type of communication which are unicast. The CCIE, or the last I can say expert level of routing, switching, or enterprise, you will understand how to assign the multicast IP addresses. So if you want to have communication, which obviously we are going to have the communication only one by one, so we are only our dealing till end of Ccna going to be for the first three classes. Now guys, an IP address, so now you got to know that only you can use, for example, someone is asking you that please assign an IP address for me, so you will just go to their adapter and settings. So, and you're just going to their properties and set up IP version 4. Go to properties, and here you can assign from these classes. For example, I want to assign an IP address from class B, 128 to 191. So I will just, here what I'm going to do is I will delete this one. I will write, so for example, 128 dot for example .16.1.1. let's say. I will assign what subnet was. I will say what is the subnet was, 255.255.255, or let's say .0.0, 128.16.1.100. So you're just assigning like this only. But right now you don't know what is default gateway or what subnet mask. I will tell you what is them. But for as of now, so you know that while assigning an IP address for any node in the device and a network, we only use unicasting, not multicasting IP address. Just totally you can forget about this, but please remember the range of IP address, because you cannot assign IP address from the multicasting. Let me just demonstrate an example for you. I will assign an IP address, for example, more than 223, more than class of C. I will assign one IP address from class D, let's say 224C. Even it's not allowing me to go for the further octets. It's saying that 224 is not a valid entry. Please specify a value 1, 2, 2 to 3. So from class A to class C, because 224 is related to class D, and multicasting IP assignment is different, not like this. You're not going to go to your adapter and you're going to assign it. So that's related to CCIE. If you further want to study, then you can learn that. So in this IP address, there's so now you got to know that IP address is 4 octet, and you have to use from this class, these 3 classes. But there's one more thing in IP address. In IP address, we have 2 ports, guys. Inside an IP address, we have 2 things. IP address consists of 2 ports. I mean that this 32-bit address or 4-octet address or 4 decimal address consists of 2 ports. That the first port is the network port or portion, and the second one is the host portion. What does it mean? For example, here's a building, and inside this building, and this building name is, let's say this building name is building A, and inside this building we have, for example, we have so many flats available. These flats can have their own numbers, for example 1, 2, for example 3, 4, 5. Let me ask you one question. So if you want to refer about this building, flat number 5, what you are going to say? You will say that this flat address is A5. Or if I am asking that what is the address of this flat, you will say that A1. About this flat, A2 or A3. Why you are having A common between them? Because you know that all these 5 flats are located in this building only. But if say, let's say there's some other building, and the building B is, the building name is, let's say building number B, and inside this building B we have the same flat number 1. So means the flat number is still 1, but the building name has changed to from A to B. So while you're referencing this building, this flat, so what you're going to say, that you will say that B1. Though this 1 is common between these 2 flats, the flat A and B, but still, since their building is different, so you're changing the B. But unless the flat is within the area of this building A, so you're just referencing the A. What do I mean by this? That in IP address we have 2 ports. The first port is network, and the second port is host. The network will identify that your host is related to which building, kind of say which building, or technically we can say which subnet. In terms of technical, we are using subnet. So you will say, based on the network portion of your IP address, you will say that this host is related to the which building, and the host portion is your flat address, which technically we call them as host ID. So I hope you understand it now. Network portion and the host portion. What is the advantage? So what is the common between the host portion and the network portion? There are some advantages, guys, that you will get. If 2 flats, if I am talking non-technically, if 2 flats are in the same building, then they can communicate with each other, without any type of configuration. So what does it mean? You will understand later this concept very technically, but as of now what I'm saying is, if 2 flats are in the same building, means if 2 hosts are in the same subnet, they were together in the same subnet, then both of them can communicate with each other without any configuration, just as an IP address for all the flats or all the hosts in the same subnet, and ping from wherever you want to go. But if you want to communicate from building A1 to building B1, then there is an issue for you. You cannot communicate because now your network portion has changed. Now your network is changed. Subnet is changed. So in this case, you need to do some configurations. What is the configuration? That's here, guys. And see, when there was a concept here when I was assigning an IP address. You saw here that is default gateway. Default gateway. So what is this default gateway? It's like kind of your agent, or a kind of your principal that he knows. Actually he know all the address, all the like outside subnet address. So if I talk technically, the default gateway is the person who knows all the outside subnet address. So for A1, if he wants to go to B1, first A1 must go where? He must go to default gateway. The default gateway or the principal. The default gateway knows already. Default gateway in every subnet, guys, in every subnet. Later on, practically, we will do this all. But default gateway in every subnet have the address of all the buildings, building B1, B2, building C, building D. All the information is in the default gateway, but the information is not with the host. But if this host wants to go, for example, if A1 wants to go with A2, then it doesn't need to go with default gateway. He already know that we are in the same subnet, so we don't need to go with default gateway. But if he wants to go somewhere else, so he must or she must go to default gateway. Now, so I hope you understand this, but still you are having a question. The question is that how I know that what is my network portion, and if I have an IP address, let's say if I have an IP address of 192.168.1.1, what do I know that which part of my IP is my network, who I know actually, and who I don't know, which I have to go with them to ask default gateway. Now here there's obviously really simple method. Really simple method. What is the method? It says check your class of IP. Class of IP. Check your class of IP. If your IP is from the class A, if your IP is from the class A, then it means, for example, 10.1.1.1. This is related to class A, isn't it? Yes. So it means here, if the IP is from the class A, then your first octet is your network ID or your network portion, the common portion. The rest are uncommon. For example, 10.1.1 and 10.3.4. For example, .5, let's say. Whether they are in the same network? Yes, because they are from class A and their first portion or the first thing or first octet is common. So they are in the same network. They can directly communicate and they don't need to go to default gateway to know. So for example, the 10.1.1 don't need to go default gateway to know where is 10.2.3.5 because they are in the same network. But if I ask you that whether this IP address, for example 11.1.1.1, though they are from the same octet, see 11 is also from the from the same class, but their common portion is changed right now. The first octet is changed, so they are not in the same subnet. So for example, on if 10.1 want to go to 11.1, he must go to default gateway to find the address, to take the address, how to go there. Okay, so if your class is class B, your IP is from class B, and the class B, for example 172.16.1.1, let's say. In this case it says that both the first two octets must be common. Means your first two octets is your network. So whomever has the same, see, whomever has the first two octets same, for example 172.16, rest doesn't matter. They're all your brothers and sisters, I can say. Rest doesn't matter. Only what matters is that first two octets must be same. Are you getting it? So if your IP is from class B, the first two things must matter. Even if let's say it is 172 and the other port is 15, the second octet is 15, and the rest whatever it is, still they are not common because It's not the condition only based on the first octet. That was class A, only first octet matters. But in class B IP address, both the octets must be common in order to call them that they are in the same subnet. But if it is a class C IP address, guys, class what? Class C. For example, 192.168.1.1. In this case, they are saying that your first three class must be same. Means your network is your first three class. Okay. For example, tell me whether these two can communicate or not, or they need to go to default gateway. Yes, I can understand that you know that these two can communicate because they are from class C. So if they are class C, directly check first three octet are same. So means other port really doesn't matter, last octet, whatever it is. It's like, for example, it's flat number 1, that's flat number 100, but they are in the same building. So they can communicate and they don't need to go anywhere else. But if I give you an example of like 192, same, 168, same, 2.100, let's say, whether they are same or not. No, they are not, because the first three octet, now we have a changes in the third octet. So in this case, we cannot say that they are in the same subnet. In order to go to 2.100, we have to go first to default gateway and ask him that where is the 2.100. He will tell you back and you can go there. How you will ask and how he will give you the information, guys, to go to 200. That is our routing lecture. Okay, routing protocols or routing lecture. We will understand this in our routing after finishing of our IP addressing, how to go to the networks which are not in our same subnet. Okay, so now there is another question solved here. Here you will see what? Here you will see the subnet mask. The subnet mask. That is 255. That's always either 255 or 0. Either 255 or 0. It cannot be any other number, okay, as of now. So that's what's the subnet mask? The subnet mask as a number, or I can say as a number. Yeah, it's the structure of subnet mask is more like an IP address, but it's always either 255 or 0. It specifies, guys. So now we understand that if the class C is, if the IP address is from class C, first three are the network. But how to learn, how to teach the computer and how to say for the computer that your first three octets is your network. If our IP is, for example, class C. See, for example, what I'm saying is, for example, 192.168.1. For example, 100.1. So I know, because I'm an intelligent student, and I know that the IP is from the class C, and the class C first three portion is common. Okay, so the first three portion is our network. So I will, but how to teach or how to say for computer that hey, my computer, you should know that first three must be common if you want to ping someone, if you want to ask someone that I want to, like if you want to say hello for someone, you should first check that whether that person has the same subnet or not. Then you say hello. Otherwise, you must first go to default gateway and ask him how to say hello for other persons. So how to teach for computer? That is through the help of subnet mask. The subnet mask is really easy, guys. It says if your IP is from class C, then your subnet mask is 255.255.0. If your subnet is for example 172.16.1.1, for example, that's class C, isn't it? Yes. So it says your class B. So what's your subnet? 255.255.0.0. And for example, let's say 11.1.1.1. So subnet mask for class A is 255.0.0.0. It's already predefined because you know first three are. Now if you realize, if you just notice that in class C first three portions are our network. So wherever that's network ID, that is 255, and wherever that's host portion, that is 0. Are you noticing it? Yes. So for the class B, in order to specify what is my network portion, I'm going to write 255. That this is my unchangeable. That must be fixed. And for class C, the first is 255. So it means that wherever they are all ones. 255 is, guys, you know that 255 and binary, that is 1. 1, 2, 3, 4, 5, 6, 7, 8. And zeros, whom? 0 is 1, 2, 3, 4, 5, 6, 7, 8. So now we understand right now that subnet, the network portion is that portion. The network portion is the portion where the subnet mask is all 1. Are you getting it? So when I'm writing an IP address like 192.168.1.1, I'm writing the subnet mask as like this: 1.1.34567 1, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6, 7, 8. So you directly understand that this is my IP and the network portion is. So you don't need to memorize. You don't need to memorize that whether that's class C or not. You just directly jump on subnet mask. Don't mechanically memorize and see how much portion is 1. Just count all of them. Yeah, so this much portion is 1, and just see that how many octets are included. 1 octet, 2 octet, and 3 octets included. So it means the first 3 are your network portion because they are all 1. So better to represent all ones as 255. 255.0. So for example, if I'm writing an IP address of 14.1.1.1 and I'm writing 255.0.0.0, so what's the this is the common portion. 14 is the common portion, and the other portions can be changed. So I hope you understand it. So while you are specifying an IP address, you must give the IP address the subnet mask, because you know that the subnet mask is going to be this for IP address of class C. But to say computer, to teach computer, to convince computer to know that your subnet mask is your first 3 must be common, so you have to write, for example, when you are writing an IP address of 192.168.100.1, you know that this is class C and first 3 portion 192.168 and that the 100 must be common, but the computer don't know that, because because computer can take any number. You should teach computer, you should say computer that, say, hey computer, this one and this one must be common. This can be changed. That's why you are putting 0 there. That the 0 portion can be changed, but the other first 3 are common. And default gateway. Who is your default gateway? This is my host address. 1 is the flat number 1. So who is my default gateway? The default gateway, or the like for example, the default is your watchman of your society, or I can say the principal of your society. So principal has a good IP address, a beautiful IP address. Principal is also living in the same flat, isn't it? It's not living somewhere another where. It's also living in the same flat, but the principal flat is located, for example, in building number 100 or building 110 or 2. Really doesn't matter. Okay, principal can be anyone. You can assign anyone as a principal. Okay, in routing lectures you will understand that who you should assign as a principal of your building, or who you can assign as a default gateway of your subnet. So from now onwards I will talk totally technical. I will not use the common dictionary or vocabulary. Okay, so you assigned it, and now my computer is related to the network of 192.168.100.1, and whomever have the IP of first 3 portion common, I can communicate, and I don't need to go anywhere else. So guys, this was a lecture about the IP addressing. I hope you understand it very well. In the next video we will have the subnetting part. It's really important, guys. I will say you there is a problem, a really big problem with this type of subnetting, which I will explain that problem in the next video. So have a nice time. Bye bye.